I think water will be one of the biggest problems that we'll be facing over the next century. Access to clean drinking water is already difficult for many parts of the world, and being able to harness water from the environment, essentially from air, which often just evaporates, I think is an idea that has potential all over the world.
In a remote corner of northern Arizona, the Navajo Reservation is home to an ancient and resilient people. This vast and arid landscape has always challenged those who live here. And for many, the basic task of obtaining water can be an arduous process. But a unique program at Arizona State University has been working to lessen this age-old struggle.
What we do in Innovation Space is teach students transdisciplinary, sustainable new product development. How do you create new products and services in a way that improve people's lives, improve society, and minimize environmental impact? So our goal has been to create a studio environment at ASU where students from 3 disciplines, design, business, and engineering, can work in teams, be creative, solve really important problems, and finally transform the world with the work that they do.
Innovation Space collaborates in the development of product concepts with partners such as corporations and other university researchers, including the Center for Nanotechnology and Society at Arizona State University. The center examines the societal impacts of nanotechnology, and for one team of students, this particular partnership has helped in the development of a new way of providing indigenous peoples with clean drinking water. It is a project that proved to be especially compelling for the participants.
One of our main focuses from the very beginning was to look at equity. So our user group ended up being Native American reservations, which often, in a very much higher percentage than the rest of the U.S., don't have access to clean water or electricity. And so focusing on that made the product a lot more meaningful and gave us a real reason to learn about our user and to do something that could help the world. So that was exciting for all of us, I think, and very motivating to work hard.
In Innovation Space, we're supposed to focus on a specific user base. And we were given 4 focuses for our project. It was energy, equity, nanotechnology, and biomimicry. A lot of us didn't really know what any of those 4 things meant. We quickly began to learn what they meant. And we knew that there was a huge water issue on the reservation of getting water to the local dwellings. So we knew that was what we wanted to solve. We wanted to bring water to their houses and make it much easier for them to have access to that water, a clean source of water.
As part of its ongoing commitment to develop new environmentally responsible design strategies, Innovation Space has been working closely with the Biomimicry Institute since 2008.
Innovation Space is really unique. They have an ethic. It says not only does it need to be a profitable product that might do well in the market, but it also needs to be good for society. And it needs to be good for the environment. And adding that criteria to what it is they're going to work on, and it changes everything. And that's why I'm excited that biologists are now starting to work with Innovation Space students. What normally happens at design tables is that designers get their inspiration by flipping through magazine, or by looking at catalogs, or by taking a shopping trip and looking how other people have solved the challenge. This is a different kind of inspiration because it's how have other organisms solved the challenge. And since they don't know biology, they need to team up with a biologist. So uniquely enough, that's what Innovation Space has done.
We want to make sure that everything we design minimizes impact on the environment. One of the ways to think of sustainable development is to look at biomimicry, to look at how nature has been solving problems for millions of years and how to incorporate those ideas into the problems that we as human beings are facing.
Biomimicry was new to me. So what we did was we worked with Janine Bennis from the Biomimicry Institute, and she came in, her team came in, and they taught us how to look at nature for unique solutions to real-world problems. And you don't necessarily copy nature, but you look at how nature would solve that problem in a sustainable way, and you apply that to your problem and create the solution.
The product that Team Pinpoint developed to provide an easily accessible supply of water is called Everwell, a device that could literally snatch this scarce resource out of thin air.
So the team was trying to figure out how can we capture moisture from the environment, not lose it to evaporation, and make it available for drinking. What they did was they looked at models in nature, and one of the creatures that they discovered could be really interesting to study is the Namib beetle.
Found in one of the driest places on Earth, the Namib Desert in Africa, this beetle has evolved a highly effective strategy for collecting water. On its back are microscopic features, hydrophilic bumps, which attract moisture from condensation, and hydrophobic channels, which then transport it to the beetle's mouth.
As the surface attracts more and more water, the drops of water grow in size, and as they get too big to stay on the bump, they roll down the channels on the beetle's back directly into its mouth. So it has a really interesting mechanism by which it's able to attract moisture from the environment. Team Pinpoint, which developed Everwell, took that idea, and their product has these panels that use these surfaces which are partly hydrophobic and partly hydrophilic, attracting moisture from the environment, channeling it down to make it available for people to access.
At the heart of the Everwell design strategy is nanotechnology, the emerging science of manipulating materials at the molecular level for a specific purpose. It is a technology which promises to revolutionize many aspects of our everyday lives.
One of the cool things that Innovation Space has been working on, and that Everwell is a really interesting example of, is the nanoscale, is where physical, electrical, and chemical and biological phenomena all converge. So here we have the opportunity, working with Innovation Space, to give training to students who are then going to move out into the economy and work with this material. They will have known when they get there what nanotechnology is. They will have known some of the issues in trying to create a product out of something that you can't see. And so they will have, through this experience, begun to anticipate the kinds of things that will actually get designed with nanotechnologies.
One of the really key things for the Center of Nanotechnology and Society is to help students, to help policymakers, to help scientists understand the broader context of a technology. We're very interested in encouraging people to recognize that technology is made and not born. There's more to product development than the thing itself, that the thing gets embedded in people's lives in very profound ways, and to begin to unravel some of the dilemmas that might come up, some of the new ethical issues that might be raised. How will people use the technology? How might that change how they live and work? What's interesting about Everwell is that it came about from the students trying to understand Native American communities and what their energy issues were, what their water issues were, and from the needs of the community, to try to find a technical fix and to really design the technology all the way through so that it would serve the needs of the community. And so I think that that's a really unique contribution. It's an incredibly unique and important way to develop new products.